All right, so we've done some factoring of polynomials before. We were doing specifically quadratics. So now we're going to look at other types of polynomials that are considered factorable. Okay, so we're going to look at all kinds of stuff. So for instance, we're going to look for, can I factor out any common terms to make it simpler? Looking at different types of methods, some of them that look like the quadratics but maybe have different powers, so we can still factor it the same. Looking at something called factoring by grouping, and we're also going to look at something called the sum or difference of two cubes. Okay, so I'm going to look at these example 1 problems so that we can kind of think about those in the different forms so that we can practice them accordingly. Let's start with example 1a, which is x cubed plus 2x squared minus 15x. So what I see first is that every term has one x in common. So I'm going to factor that out so that I now have x squared plus 2x minus 15. Okay, so I'm going to ignore this for the moment, and I realize that this just looks like what we were doing before. So I'm going to look for two numbers that multiply to negative 15 and add to 2. So that's going to be what? 5 and negative 3. Alright, so I've got my x squared, my negative 15, my 5x, and negative 3x. So that's going to give me x plus 5 and x minus 3. So now my fully factored form is x, because I pulled that out initially, times x plus 5 times x minus 3. Now since it doesn't say solve, I would stop there since I went ahead and did the factoring. Let's look at b. 5y cubed plus 10y cubed minus 40y squared. Okay, I want you to look at, this should be a 5. I can't read. Okay, so I want you to take a minute and try this one for yourself. Factor out anything that you possibly can. Part C is 4z to the 4th minus 16z cubed plus 16z squared. Again, I want you to factor out what you can and see what you get. Alright, now let's look at the last one. I've got x to the 4th minus 29x squared plus 100. Now when I look at this one doesn't have any factors in common. But what I do notice is that it kind of looks a little bit like what we were doing before. Like if I were able to change this to a 2 and just make this a 1, I could factor that. So I'm going to think of this in that exact same manner. Okay, so I've got x to the 4th and 29. So I'm going to look for what multiplies to 100 and adds to negative 29. Right, that's a negative. Yeah, okay. Okay, that would be negative 25 and negative 4. So when I fill out this box now, I have an x to the 4th, I've got my 100. So now instead of x's, this is going to be negative 25x squared and negative 4x squared. So when I split up my x to the 4th, it's going to become, instead of x and x, it's going to be x squared and x squared. So now this is going to become minus 25 and minus 4. Your goal when we're factoring is to get these down to be singular x's, not x squared. So now I'm not done. I need to factor these. Okay? If I use my special rules and I look above from when we were multiplying, these are difference of two perfect squares for both cases. If I went ahead and factored, I'm missing the middle term, so I need for the first one what multiplies to negative 4 and adds to 0. And that's 2 and negative 2. So I've got x, negative 2x, 2x, and negative 4. So that's going to give me minus 2 and plus 2. Okay, and I'm going to do the same thing over here, and you're going to get x minus 5 and x plus 5. So my factored form is this. Right? If I factor it in the exact same way as I did the one before. Okay? So I'm basically in this video just going to kind of give you an introduction, and then we're going to do more in class. Okay? So I'm going to show you what the sum or difference of two cubes is and how to factor that. And then I'm going to, we're going to do grouping together in class. Okay, so the last part of this video is going to be now looking at sum and difference of two cubes. Okay, these formulas should be memorized. So I'm looking at these, the sum of two cubes to start. So I'm going to look at x cubed plus 64. X is a perfect cube, 64 is a perfect cube. So the sum of two cubes formula is whatever I cubed, so x was cubed and 4 was cubed. So I get x plus 4, and then it becomes, so this is my a and this is my b. Okay, so my a, so now it's going to be a squared, so I'm going to have x squared minus a times b, so in this case that's going to be 4x, and then plus b squared, which is 4 squared is 16, factored. Okay, the same idea can happen with this difference of cubes. You just got to memorize the formulas. So that was example A. If I look at example B, I have to first pull out what I can. Okay, I see that I can pull out a 5 and a y squared, and that's going to leave me with y cubed minus 8. Okay, y and negative 8 are both perfect cubes, so I've got my 5y squared. That's just going to follow down. So that's going to give me y minus 2, because 2 cubed is what gives me the 8. Okay, then it's y squared plus 2y plus 4. Done. Okay, now you'll see if you try to factor this or this, it is not factorable. There's nothing that multiplies to 4 and adds to 2. Okay, I want you to try part C by factoring out what you can first, and then using your either sum or difference of cubes formula.